Good day, students. By the way, I am Miss Resume Silagan, and on this video, we're going to talk about deferred annuities. So this video is a continuation of the topic about annuities. So what is deferred annuity? So again, deferred annuity is another type of annuity, but it starts at the later date. Because when we say about deferred, it means later. So the period between now and the beginning of the term of the annuity is called the period of deferral. These are the two different stages in deferred annuities. So we have the accumulation stage and the payment stage. So take note, in the accumulation stage, you have to apply the discounting or compounding formula. However, after this end of period of deferment or the end of period of deferral, so you are going to undergo with the payment stage. So on here, you will apply the appropriate annuity formula. So in accumulation stage, on this stage, a single payment is allowed to earn interest for a specific period. So there are no annuity payments during this period of time. So thus, the period of deferral exists on this stage. So during the payment stage, however, the annuity takes the form of depending on its annuity types and starts at the beginning of this stage. So on this stage, you have to apply the annuity formula. So the maturity value of the accumulation stage is the same as the principal for the payment stage. So for deferred annuities, the most common unknown variables are either the present value, the length of the period of deferral, or the annuity payment amount. So you have to take note of this potential unknown variables. So actually, there is no additional formula involved in deferred annuities because this is the combination of compounding or discounting and annuities. So let's have here an example. So Fraser is 33 years old and just received an inheritance from his parents' real estate. So he wants to invest an amount of money today such that he can receive $5,000 at the end of every month for 15 years when he retires at age 65. If he can earn 9% compounded annually until age 65 and then 5% compounded annually when the fund is paying out, how much money must he invest today? On this problem, you have to calculate the single payment that must be invested today. So there are two given. This is the given during the payment stage, and this is the given during the period of deferral or the accumulation stage. Here, no, the given, it is the ordinary annuity. Why? Because Fraser should receive $5,000, which is the annuity payment, at the end of every month. So you have to take note. So this is an application of the ordinary annuity. So here, the annuity payment, as I've said, we have $5,000. The periodic interest rate is 0.05 or 5% compounded annually. So you divided 0.05 by 1, so you have this 0.05. And the number of payments over the years, we have your payments per year, which is 12 multiplied by 15 years, which is equivalent to 180. Then the compounds per year is in annual, so you have 1. And the payments per year is 12. So this is the given, right, for the ordinary annuity. And this is the given during the period of deferral. So your future value here is equivalent to PV ordinary, or the present value of the ordinary annuity. So your periodic interest rate here is 9% compounded annually. So you divide 0.09 by 1. So therefore, your periodic interest rate here is 0.09. And your N here, or the number of payments over the year, since your payments per year during this period is 1, so you multiply it by 32 years. So you calculate the present value of the ordinary annuity using this formula. So it is given that the compounds per year and the payment in 1 year are not equal. So you have to use the formula for general ordinary annuity. So your first step is to calculate the present value of the ordinary annuity using this formula. So take note that in the given, the compounds per year and the payment in 1 year are not equal. So we can conclude that this is an application of the general ordinary annuity. So you have to use this formula. So using that formula, we substitute all the given values. So you will come up on this, okay? So we have here our annuity payment, which is $5,000. Our present value of the ordinary annuity is unknown. We have here the periodic interest rate, which is 0.05. The compounds per year is 1. And the payment in 1 year is 12. And also the number of payments over the years is 180. You have to resolve on this, which is 1.05 to the raise of 1/12. Then you will get the value of 1.004074124. So next step is to resolve for this value. You have to calculate the 1.004074124 to the raise of negative 180 using your calculator. So you will get the value of 0.481017981. And this value arrive because we deduct the quantity 1 from 1.004074124. So we get the value of 0.004074124. So now we have to resolve for this value. You have to deduct this from quantity 1. Then the result is 0.518982919. So you divide it by 0.004074124. You have 127.38515112 multiplied by 5,000. You will get the present value of ordinary annuity, which is $636,925.76. So please be reminded that during the process, you have to take note that you have to put the whole decimal values. You don't have to round it off because it is prone to discrepancy. So in order to avoid that discrepancy, you have to put all decimal values during the process. And in the final stage, maybe, or in having the final answer, maybe you could round it off by 2 decimal places, just like this one, okay? So now, let's calculate the present value of single payment using the given values of the deferral period or period of deferral and the discounting formula. So you have here. So you have to take note that in the given, the future value under the period of deferral, it is given that the future value is equivalent to the present value of the ordinary annuity. And we already get that value. So we have to calculate the present value of a single payment using the values given of the period of deferral. So using the discounting formula, you have this, wherein you will find the present value. So you simply divide the future value, which is $636,925.76. Then you have here the 1, this is already given, plus your periodic interest rate, which is 0.09 or 9% compounded annually. So you have to divide it by 1. And here, this is your N. So you have 1 times 32, okay? So you'll be able to get this 1. So we have to resolve this 1.09 to the raise of 32. Then we will get the value of 15.76332,879. So simply divide this amount by this, dividing the two amounts. So we will be able to get the present value of $40,405.54. Therefore, Fraser should invest $40,405.54 today in order to sustain 180 withdrawals of $5,000 on his retirement in the future. So let's have another example. We have to apply the annuity due. Why? Because he wants to pay $2,500 at the beginning of every month for 10 years. Then the annuity payment here is $2,500, and the periodic interest rate here is that 4.3% compounded semi-annually. So you simply divide 0.043 by 2. So your periodic interest rate here is 0.0215. And the number of payments over the years, so take note that your number of payment in 1 year, or PY, is 12. And there are 10 years during this payment stage period. So 12 times 10 years, it is equivalent to 120. And your compound number in 1 year is 2 because it is compounded semi-annually. So this is the given. However, during the period of deferral here, the present value is given, which is $50,000. But you have to determine first the future value, which depends on this. Now you have to identify the present value of the annuity due. And here, during this period, the interest rate is 8.25% compounded quarterly. So you simply divide 0.0825 by 4. So you have this periodic interest rate, which is 0.020625. But here, you have to find for the N. So you have to find how far, in advance of the start of the annuity. So that refers to N. And here you have given the compound frequency, which is 4, okay, because it's compounded quarterly. So on this, you have to calculate first using the present value of annuity due. And this is the formula for the general annuity due, because take note in the given here, the CY is not equal to PY, or the compounds per year is not equal to the payment in 1 year. So you have to use this, okay? So you have to take note of this formula in calculating the present value of your annuity due. So your first step is to calculate the present value of annuity due. So using the formula, you simply substitute the given values, okay? So you have here your annuity payment, which is $2,500. Your periodic interest rate here is 0.0215. And your compound frequency is 2. And your payment in 1 year is 12 because you have to pay each month, right? And here you have your N, which is 120. So since it is a present value, it is negative 120. Okay? So let's first resolve this. 1 plus 0.0215. So you have 1.0215 here. Then let's resolve the 1.0215 to the raise of 212. So using your calculator, you will obtain this value, which is 1.00355168. Okay? So now let's resolve this value, which is 1.00355168 to the raise of negative 120. And let's also deduct 1.00355168. So you have to deduct the 1 from this value. You will obtain 0.00355168. And your 1.00355168 to the raise of negative 120. So you will obtain this value, which is 0.6534804.285. So now let's calculate this. You have to deduct this value from 1. You will be able to get the value of 0.3465195,715. Then dividing the two values, you will obtain 97.56585,435. So you multiply this by 1.00355168, then you will obtain the value of 97.91237392. Then you multiply this on the $2,500, then your present value of the annuity due is $244,780.93. So your next step is to determine the total number of payments, or N, that is compounded quarterly during the accumulation stage using this compounding formula. So you have this compounding formula. So using this formula, you have to take note that the future value is equivalent to the present value of the annuity due, which is 244,780.93, right? And here, this is your present value, which is $50,000. And your periodic interest rate, which is 1.020625 to the raise of n. So on this, you have to resolve this value. You will obtain this. Then you have to cancel 50,000 out by simply multiplying both sides by 1 over $50,000. Then on this side, you have to cancel that out. Okay? Then this 244,780.93, you multiply it by 1 over $50,000, or you divide this value by $50,000. And yeah, you will be able to get this structure. And after dividing these two values, you have 4.895618. So now we have to transform this one. You might think that we have to transform this equation into log form in order to find n. And if you think of that, then you're right. So you have the ln here. And using your calculator, you will get the value of ln 4.895618 and ln 1.020625. So the ln 4.895618 is 1.588,340, and the ln 1.020625 is the 0.020415. So dividing the two values, you will be able to get n, which is 77.801923. So your next step is to calculate the number of days, assuming that there are 91 days in a quarter. So in years, you simply divide 77 by 4 because you obtain this 77.801923. Then you have 19.25 or 19 years and 3 months. Then the 0.81923, you multiply it by 91 days. So remember here, this one, 81923, you multiply it by 91 days and you will get 73 days. So therefore, Bashir needs to invest the $50,000 for 19 years, 3 months, and 73 days before the annuity starts. So isn't it amazing that you can get the time that you need to invest this amount? So let's proceed to another example. John purchased a dining set for 80,000 on May 13, 2009. She paid 10,000 pesos cash and agreed to pay the balance plus interest at 9.50%, compounded annually in 14 equal payments, with the first payment due on May 13, 2012. So now, what is the size of each payment? So it pertains on the annuity payment. So your first step is to calculate for the balance payment. So take note that John has already his advance cash payment of 10,000 pesos. So you have to deduct 10,000 from 80,000 and his balance payment is 70,000 pesos. So it is given, no, during this payment stage that the present value of the annuity due. Why is it annuity due? Because the first payment is not at the end, right? This is at the beginning of the payment interval, if you notice here, because he purchased a dining set on May 13, and the first payment due is on May 13 also. So it is an example of the annuity due. Okay? So here, the annuity payment is unknown, and the periodic interest rate, which is 9.50% compounded annually, so you have 0.095, and there are 14 payments. So the number of payments over the years is already given. And here, the present value during the period of deferral is 70,000. But you have to find for the future value. And your interest rate or periodic interest rate is the same on this given annuity due, which is 9.50% compounded annually. So you have 0.095. And the n here is 3. So first, you calculate the future value of John's balance payment. So take note that the balance payment of John is 70,000 pesos, and that is the present value, right? So using the compounding formula, which is this one, and the given values, you have to substitute the given values in this formula. So you have your present value, which is 70,000 pesos. And 1 plus 0.95, you have this. And n, which is 3. So 1.095 to the raise of 3 is equivalent to 1.312932375. So you have to multiply this value to 70,000 pesos, which is 91,905 pesos and 27 centavos. So your next step is to calculate the payment of an annuity due, because in the problem, the question is what is the size of the payment, and that pertains to the payment of an annuity due. So take note that the present value of the annuity due is equivalent to your future value, right? So you have 91,905 pesos and 27 centavos. This is your present value of the annuity due, which is equivalent to the future value that you already solved. and the annuity payment here is unknown. Then the CY here and the PY here are given, which is 1. So when we divide 1, which is CY, and PY, which is 1, it is equivalent to 1. And you can put here an imaginary 1. Same here and also here. So it remains as is. Then you have first to resolve for this. So 1 plus 0.095, you will obtain 1.095 to the raise of negative 14. And here we have also 1 plus 0.095. So you have 1.095. So you deduct the 1 from here, you will obtain 0.095. And your 1.095 to the raise of negative 14 is 0.2806740954. So you have to deduct 0.2806740954 from 1. Then you will get the value of 0.71932599046. So now you have to divide this amount by 0.095, and you were able to get 7.5718516273. And you have to multiply this by 1.095. Then you will get the value of 8.2911775332. So in order to get the value of P, you have to divide both sides by 8.2911775332. So you have to cancel this out. Then dividing the 91,905 pesos and 27 centavos from this value, you will get the quotient of 11,084 pesos and 71 centavos. And this is your annuity payment. So therefore, the size of John's payment is 11,084 pesos and 71 centavos. So this ends about the deferred annuities, and I hope you learned something on this video regarding with the topic. And if so, then congratulations. So by the way, this is Ms. Resume Silagan. I want to say thank you and goodbye.